Okay, so for today I'm going to talk about one of those more advanced integration type problems. I do want to point out the 3 additional integration things that you need to know as a BC student are integration by parts, integration using the method of partial fraction decomposition, and then improper integrals. And those improper integrals are either going to be ones that there's a discontinuity somewhere within the bound or at one of the ends, or it's going to have a bound that's going to be infinity. So I highly suggest you go back and you look over those, especially integration by parts. I would feel like that would be something that you would probably end up seeing, and you'll see some of that in your quiz. Okay, so it says consider the family of functions where you have f of x equals 1 over x squared minus 2x plus k, where k is constant. Find the value of k for which the slope of the tangent at x equals 0 equals 6. So the first thing we're going to need to do to find the slope of the tangent is figure out what is the derivative of f of x. Okay, so I would maybe think of f of x as x squared minus 2x plus k raised to the negative 1. So you could just use chain rule. When you start taking the derivative, you'll drop that negative 1 down in front. X squared minus 2x plus k will now be raised to the negative 2. Don't forget about the derivative of the inside, so you'll have 2x minus 2. So if I clean that up, that's going to come out to be 2x minus 2, actually really negative, times 2x minus 2, all over x squared minus 2x plus k squared. Okay, so they are asking us to find out where the slope of the line tangent to the graph of f at x equals 0, so you're going to plug in x equals 0 and set the whole derivative equal to 6. Okay, so if I start plugging in, so this becomes 2 times 0 minus 2, all over 2 squared, oh sorry, not 2 squared, okay, 0 squared, 0 squared minus 2 times 0 plus k, that whole quantity squared, and you set that equal to 6. So as I start cleaning this up, you'll end up getting something like on the top that comes out to be just positive 2 all over k squared equals 6. As I cross multiply, this is going to lead me to having, sorry about my arrow, 6k squared equals 2, or k squared equals 2 over 6. You can reduce it or you can leave it as 2 over 6. And eventually you'll find out that k equals plus or minus the square root of 2/6 or 1/3. Obviously, again, you're talking about where k is specifically greater than 0, so you're not going to include that negative. So you get k equals positive 1 over square root of 1 over 3, which could also be 1 over radical 3. Again, remember when it comes to actually, writing like arithmetic answers, you do not have to simplify. You don't have to rationalize. You don't have to make it so that you have a radical just on the bottom. That is fine to leave it as k equals the square root of 1/3. Okay, so now we're not going to be using the answer for k in part A. That was just part A. We're still going to be using the same original f of x expression, but now we're going to be using it in a different way. So it says for k is equal to negative 8, find the value of the integral from 0 to 1 of f of x dx. So let me rewrite that again. F of x is equal to 1 over, let's pull that down, x squared minus 2x. And in this case, it's saying plus k, but specifically we're given that k equals negative 8, so minus 8. Okay, so we're looking to integrate that expression. So if I just tried to integrate from 0 to 1, the expression 1 over x squared minus 2x minus 8, I can't do anti-chain rule because I wouldn't have the du that I need inside, so that's how I know that I'm going to have to do something with factoring and breaking down these fractions in a different way. So again, I know it's been a little while since we did partial fraction decomposition, but one of the first steps is that you want to factor the denominator. So I would have something like, I don't know, I'll do like 1 over x squared minus 2x minus 8. And when you factor that, that becomes 1 over, what is that? X minus 4 times x plus 2, so that factors properly. So eventually that's going to break apart to become a over x minus 4 plus b over x plus 2. Okay, so that's your partial fraction decomposition. So if you remember, the idea is like, think about like, somehow trying to make a linear equation out of this. So you're going to end up thinking about like if I had multiplied x minus 4, x plus 2 to the top of each of these expressions, you'd end up getting a linear, it's not really a linear equation, but everything in one line, where it would say something like 1 equals a times x plus 2 plus b times x minus 4. Then you're going to choose values of x to plug in that allow you to solve for a and b, and then you go back and you rewrite your decomposed partial fraction situation. So the values you want to choose are the values that make those expressions equal to 0. So if I chose x equals -2, I would have 1 equals, this whole part would become 0. I would have b being multiplied by what? -2 minus 4, which would be -6. So I get 1 over -6 for the value of b. If I then choose x equals 4, okay, because again, I'm trying to make those parentheses come out equal to 0, I would have 1 equals a times 4 plus 2, which is a times 6 plus 0, so 1/6 is equal to a. So I'm going to go back up to my main problem. You're still integrating from 0 to 1, okay? And now what you're going to do is you're going to put that, 1/6 as your numerator for a and for b, okay? So you're going to go back to this expression right here, and you're going to fill in those values of a and b. So my a value is 1/6 over x minus 4, okay, plus my b value is -1/6 over x plus 2. Some good stuff that you can do when you start factoring this out, and I'm going to erase some of this other stuff just so I can get it out of my way, but some good stuff that you can do at this particular point, is that you can pull the 1/6 out front. You don't have to keep that inside there, okay? You can just rewind if you need to see that part. So I have 1/6 pulled out. I have integral from 0 to 1 of 1 over x minus 4 minus 1 over x plus 2 dx. So you're going to integrate each one using like 1 over u du type situation, which integrates to be ln. None of those u's would need a du other than what you already have. So this would come out to be 1/6 times the ln of the absolute value of x minus 4. I'll put the 1/6 outside in parentheses, and then ln of x plus 2. So now your goal is to finish evaluating this. And again, remember, you do not need to simplify, okay? You could just literally plug in the values. So so remember at this point, you're just going to plug in your numbers and then you're done. You don't have to actually simplify or anything like that. You just plug in your values, okay? So you're going to have that 1/6 is going to stay out front no matter what. So this is going to be the ln of absolute value 1 minus 4 minus the ln of absolute value x plus 2. Nope, not x plus 2. 1 plus 2. Okay, I would maybe put that whole thing in parentheses, minus ln of absolute value 0 minus 4, minus ln of absolute value 0 plus 2. And like I said before, I don't think there's any reason for you to simplify it beyond this point. They actually wrote in their AP bulletin to encourage the students not to simplify their answers so that there's no risk of making mistakes. Not to mention, think about the fact that when you're on a small time frame, there's less of a chance of you making a mistake. Okay, last question. So let me copy down that f of x again. So f of x equals 1 over x squared minus 2x, and this time it's going to be plus 1. You're now working on the integral from 0 to 2, and you're showing that it either diverges or you're finding the value, okay? So let's start by rewriting this in a slightly different form. If I were to factor this, this becomes 1 over x minus 1 in parentheses squared. You're integrating that from 0 to 2, but this is considered an improper integral because of the fact that you'll have a discontinuity at 1, which is between your bounds, so you're going to have to separate that into separate integrals. Okay, so you're going to integrate this from 0 to 1, okay? 1 over x minus 1 squared dx. And then separately, you're going to integrate this from 1 to 2. So 1 over x minus 1 squared dx. Okay, and then you're basically going to, from there, you're going to, break this up into one-sided limits. Okay, so this becomes the limit as, I don't know if you want to call it b or x or whatever, as you approach 1 from the left-hand side, okay, 1 over x minus 1 squared dx, plus the not yet, got to do the limit first, limit as b approaches 1 from the right-hand side, So you're starting at 1, or starting at b really, and going up to 2. 1 over x minus 1 squared dx. Okay, so now as I go on further, as I integrate, I'm going to think of this as x minus 1 raised to the negative 2 dx. Okay, think of like u substitution type stuff. This is going to integrate to be x minus 1 to the negative 1 over negative 1, which is really the same thing as negative 1 over x minus 1. Okay, so I'm going to sub that back in. Still doing the limit. So limit as b approaches 1 from the left. It's negative 1 over x minus 1, and you're evaluating that from 0 to b. Limit as b goes from 1 to the right. This is still negative 1 over x minus 1, and it's being evaluated from b to 2. As you start, setting this up and you look at the integral as you approach 1 from the left-hand side, you're going to end up seeing that the value of the limit does not exist. Okay, so if you take a look at this one, okay, and remember, if one of them fails, it diverges. So as I start plugging in, I would have negative 1 over 1 minus 1, which is negative 1 over 0. That goes to infinity or negative infinity. In fact, we don't even care which one it goes to. The most important thing is it's not going to a finite value. Therefore, this is a situation where this improper integral diverges. Okay? Now there's another video that I just posted on YouTube that goes over Riemann sums and a little bit of integration rules, basic integration rules, but I think as a BC student, these are the things you need to make sure you go over. I think it's kind of implied that you should basically, know how to do a basic Riemann sum or a basic integration one, but in case you want to see that, I posted that video on my YouTube channel.